Hello everyone, welcome back to TechCloud channel. Today we are unveiling the core differences between two fundamental networking models, which is OSI and TCP IP layer. So, have you ever wondered how data travels across network? Let's dive into the OSI, that's Open System Interconnection, and TCP/IP, which is Transmission Control Protocol, Internet Protocol models to understand their roles in the networking. So let's first look into the back days of OSI and TCP/IP layer. The OSI Open System Interconnection model and the TCP/IP model represent two significant frameworks for understanding and implementing computer network protocol. The OSI model was developed in late 1970s by the International Organization of Standardization, which we also call ISO. Its creation was prompted by the need for a standardization reference model that could facilitate communication between different computer system vendor and ensuring the interoperability. Means back days there was a restriction that only the same vendor can communicate to the each other, like HP PC can communicate to the HP PC and IBM PC can communicate to the IBM PC. For that reason they bring this OSI standard here. This OSI model also aimed to define a structured and comprehensive framework for network communication, breaking down the networking process into seven distinct layers like physical layer, data link, network, transport, session, presentation, and application layer. Despite being well throughout and comprehensive, the OSI model faced challenges in terms of practical implementation due to its complexity and emergence of TCP/IP, which gained widespread adoption. Now, TCP/IP, in contrast, traces its origin to the development of ARPANET, which is Advanced Research Project Agency Network, in the late 1960s and early 1970 by the United States Department of Defense. The TCP/IP protocol were developed by Winton Cerf and Robert Kahn in the 1970 to allow various type of computer to communicate on the ARPANET. TCP/IP was designed to facilitate communication across different network and become the foundation of the internet. Unlike the OSI model, TCP/IP comprises a simpler set of protocol. It has lesser set of protocol organized into four interconnected layers, which is network interface, internet, transport, and application layer. Its practical implementation and direct relevance to the functioning of the internet contributed significantly to its widespread adoption and dominance in networking protocol. In the OSI and TCP/IP, we have layer architecture which define the functionality on their layers. In the OSI, we have those seven layers. So the seventh layer is application layer. It users interface layer, we can say, where user interact with the service through an application like HTTP, HTTPS, NTP, SSH, and so on. Next, the sixth layer, presentation layer. This layer convert the code format into the readable format for the application layer. Session layer, the fifth layer, sorry. Session layer responsible for start, maintain, and terminate the session once the transmission is completed successfully. This layer is only responsible for maintaining and management of the session. Next, we have the transport layer. This layer provides an end-to-end communication between the source and the destination over protocol called TCP and UDP. TCP, Transmission Control Protocol, UDP, User Datagram Protocol. It's like a road for the data in the network. Next, we have the network layer. We call it layer 3 also. And this layer responsible for the logical transmission of the data, which is residing with the IP, ICMP, ARP, and so on. It's like a carrier for the data in the network. Next, and the second layer, we can also consider it the layer 2, most term being used. So this layer 2, and this is responsible for framing, error prevention, connection over the layer 2 sublayer like LLC, logical link control, and MAC, which is media access control. The first and last, we have the physical layer. This layer is responsible for physical connectivity, generating the data and requesting connections. It acts on behalf of the sender, and the network layer on the behalf of the receiver also. In the same contrast, we have the TCP/IP layer, which is having four layers. Application layer, this is the combination of application, presentation and session layer. So all the data reside between all these three in OSI, and in the application, in the TCP/IP layer, they are under the application layer only. Then we have the transport layer, similar like the transport layer on OSI. Then network layer, similar to the network layer of OSI. Then at the end, we have the network access or interface layer. You can call it the layer 1, and this is a combination of data and physical layer. So layer 1 and layer 2 of the OSI combined on this layer. These are these layers are followed by both end of the network, which are logically called encapsulation and decapsulation method. This method you can consider when a source send a data to the destination. So here on the screen you can see the source computer is sending some data which is being encapsulated by the three top layer: application, presentation and session are just having the data. After that, transport adding its own header, then network adding its own header, data link it's adding own header, and then sending towards the physical layer converting them and sending toward the destination. Once the data reach to the destination from the physical layer, at the receiver end, they start decapsulating it. So what will happen, one by one, all the headers which was added in the encapsulation will be removed and then presented to the application layer for the user. This is how encapsulation and decapsulation works in OSI layer. Similar to this, similar architecture being followed in the TCP/IP also. Just that at the application layer, all with the data you can see, which was combined from application and presentation session layer of the OSI. So all data on the application layer like this, and the network or access interface layer for the data and physical layer. The same thing is happening here also, but just that application is managing the data. Later on it's coming for directly on transport, then network, and then this data link and physical working as a network access or interface layer, and then being encapsulated and decapsulated here. So now the diverse conclusion are, which we mostly get confused sometime, that while OSI provide a comprehensive structure with distinct layer, TCP/IP's fewer layer proved more adaptable and scalable. TCP/IP practical implementation directly contributed to its dominance in the real world networking scenarios, especially with the exponential growth of the internet was the major reason. Both OSI and TCP models serves as a crucial framework for understanding networking process, while OSI offer a comprehensive structure and TCP/IP practically and direct relevance to the internet functioning led to its widespread adoption. So understanding this networking model is the key to grasping how data moves across the network, and that's wrap on our exploration of OSI versus TCP/IP today. Thanks for joining us today. If you have this video helpful, don't forget to like and subscribe for more informative content. See you in the next video. Thank you.